Hello everyone, today I wanted to share a new PCB project I've been working on. It's another USB accelerometer, this time called KUSBA Pro. If you've heard of the KUSBA name, you've probably heard of the KUSBA V2, which is this thing. The goal with this was to make input shaping as easy as possible. You just mounted this somewhere on your toolhead, connected it with a USB-C cable, uncommented a single line in your printer.cfg, and you were ready to start measuring resonances for input shaping. But the thing with this is, while it is possible to mount this on the nozzle, which is theoretically the best position for an accelerometer for measuring resonances for Klipper's input shaping, but while it is possible to do that with this, it is a bit more involved. You had to unscrew the nozzle and then use a 3D printed part, use the nozzle as a screw to screw the 3D printed part in place, and then screw the PCB on the 3D printed part, which is a bit complicated obviously. There are some nozzle USB accelerometers out there that do the same thing, but the thing with those is you still have to remove the nozzle and then use this nozzle as a screw to screw the PCB in place between the nozzle and the heat block. So you still have to remove the nozzle with those, which is something I really don't like doing on my 3D printers. I only remove my nozzle if I have to deal with something like a clock or something like that. Otherwise, I like to keep the same nozzle on my 3D printer at all times. It just makes life a lot easier. So with this one, the goal was to get as close to perfect readings as possible and make it as convenient as possible. So as you can see, this has a clamp. So for example, here I clamped the KUSBA Pro on the nozzle on this E3T V6 I had lying around. And the way it works is, you can see there is this 2-piece MJF printed mount and then 2 screws here and here. So you just place this over the nozzle and clamp it. Very easy to do. So yeah, you clamp it, connect it with a USB-C cable, uncomment a single line in your printer.cfg, and you can start measuring resonances. And once you're done, you just comment that single line, remove the KUSBA Pro like this, and yeah, you can go back to printing. So again, the goal was to make it as easy as possible. Another improvement with this compared to a lot of other USB accelerometer PCBs out there is the use of the LIS2DW accelerometer here instead of the more common ADXL345 accelerometer, for example, the one KUSBA V2 uses. And the reason I went with the LIS2DW here is because LIS2DW is, at least on paper, a superior accelerometer to the ADXL345 accelerometer. It wasn't supported by Klipper until recently, but now it is supported by Klipper. So again, since it's the superior accelerometer and since the goal with this was to get the best possible readings, I decided to go with the LIS2DW accelerometer with the KUSBA Pro. Another change with the KUSBA Pro is, as you can see, the size. For example, this is the PCB of the KUSBA Pro, and you can see that it's roughly half the size of the KUSBA V2. And yeah, that also means that the PCB is lighter and the mount is lighter compared to the mount you'd have for a KUSBA V2, because, well, the PCB is smaller, so less weight on the tool head, meaning less influence of this on the measurements. So again, the goal was to get the best possible measurements using this, so that's what I did with this. Just like all of my PCB projects, this is also open source, available on GitHub, so I'll link that in the description below if you're interested in this. And I do sell this on my store as well, so that's also linked in the description below. But yeah, let's take a look at the GitHub repository. And here is the GitHub repository of the project. Here we can find all the source files, so you can order your PCB from a PCB manufacturer using the data in the Gerbers folder, or modify it by going into the Easy EDA source. You can also find the files for the mounts, so STL files are under the mount folder here, and the CAD file of this is also available, which will be this file. Currently you only have the V6 version on the GitHub, but I will upload these two later as well after they're tested. So the middle one here is for a V6 style standard size nozzle. This one will be for CHD and Nozzle size nozzles, and I'm also experimenting with making one available for Revo nozzles as well. So yeah, not sure about the Revo one. I am working on it though, and if it works out, then I will release this as well. The CHD/Nozzle one will be released for sure, because yeah, it is very similar to the other one. So again, by the time you're seeing this video, it will probably be on GitHub already. Here you can also find a bunch of vendors for this. Currently I'm selling this, and in Europe Lab 4450 is selling this, but there will be more vendors as well. A few vendors contacted me about selling this, so yeah, by the time you're seeing this video, or maybe later than that, there may be more vendors available on the GitHub page. So yeah, you can find them here. You can also find instructions for using this here, and this also includes the flashing instructions. You can also find instructions for assembling the mount. The ones I'm selling will become pre-assembled, but if you self-source or buy from a vendor that doesn't assemble them, then you can find the instructions here, including a video of the assembly of this. So again, all of this is in the GitHub repository, which is linked in the description below. If you are in the US or Canada or Australia, and if you want to buy directly from me to support the development of open source projects like this, the link to my store is also linked in the description below. And as I said, I ship to US, Canada, and Australia, though I ship from the US, so customs is something you'll have to deal with if you're international. And yeah, again, that's also linked in the GitHub repository as well. And as I said, this is open source and licensed under GPL v3. I've benefited a lot from open source projects in the past, from projects like Klipper, Boron, etc. So I'd like to contribute to the open source community. So yeah, again, if you're interested in this, check the GitHub link and my store's link in the description below. But speaking of my store, I decided to not make a dedicated video about this, but yes, I'm now selling a lot of my PCB projects on my own store. So here you can find projects like the original KUSBA, KUSBA Pro, Nevermore sensors, Nevermore PCBs, including the Stealth Max. I don't think I ever talked about this in a video, but you might have seen the original Nevermore Max 2 PCB I did, and I've adapted that to Stealth Max as well. PyCan and a bunch of other projects here as well, including some that are not mine, like Pinky. So yeah, this is a great way to support the channel if you're interested in this. I don't really like to promote this sort of stuff. I don't think I've ever mentioned my Patreon, for example, in a video, but here you're actually getting something for your money instead of, you know, throwing money at me on Patreon or YouTube memberships or whatever. So yeah, if you like to support the development of open source projects like this, I have a store now, and again, it's linked in the description below. And to celebrate the opening of my store, I'm running a small giveaway, so this will also be linked in the description below. The giveaway is open to US only. You can win a Nevermore electronics bundle, either Stealth Max or Max. Stealth Max bundle has the Stealth Max PCB, 2 sensor PCBs, one soldered on the main PCB, and a PyCan, which is a USB to CAN bus adapter. And the Max bundle has the Max 2 PCB and 2 sensor PCBs. So those, or 2 KUSBA Pros, or 3 PyCans, which is, as I said, a USB to CAN bus adapter. So the store and the Gleam link is linked in the description below. But that's it for this video. I hope you found this project interesting. If you did, please leave a like down below, and thanks for watching.